Hello and welcome. My name is Dylan. I graduated from university with my Bachelor's of Science in Computer Science. I've worked with C++ a little bit when I was in university because I helped I helped TA. I was an assistant for a teacher for the Intro to C++ course. I've done it for a few years. I really enjoyed it. I really enjoyed teaching Intro C++ material to new programmers, and I really enjoyed watching them be excited about learning programming. So I'm hoping that this little video series that I'm going to attempt to do is going to help others get into C++ too. It's not really, I wouldn't recommend C++ for most people to begin with programming. There's other languages like Python, which are a lot more friendly in a way that it reads easier. C++ has a lot of what we call syntax that may be confusing or hard to understand why it's being used, but if you start with C++, I really think that you will have a stronger understanding of programming languages in general, and you will be better off when you try to learn other programming languages. Whereas if you went from Python and you try to learn others, I think it would be a little bit more difficult. So, and my goals for this video are to help you guys, first of all, help set up a thing called WSL, as you can see on the screen here. It is going to be a thing that is Linux, but it's in Windows. What it's for is to help emulate a Linux environment on your Windows machine, and we call that virtualizing. If you don't understand what that is, don't worry about it yet, but it's a easy way to get, what do we say? I think it's easier to develop in Linux, in my opinion. In Windows, you have to go through things like MinGW, and all these other weird things for compiling C++. I think it's a lot easier for you to run a few things in Linux, and you'll learn as you go, and you'll feel cool. You'll feel like a hacker. So here's a little clip of how you would run through that, how you would run the command, and then you just need to reboot your computer. And when you reboot, you can install Ubuntu, which is what I use. It's a very lightweight operating system, and it kind of comes with most of the things you'll need. You just need to install this and this. So now that we've got that installed, I recommend that we install the code editor. Most people might use Notepad++. However, because we're going to utilize WSL, I really recommend that we use Visual Studio Code. The reason that I recommend using Visual Studio Code is because we can get an extension within it that helps us connect to WSL, that beautiful Linux environment you just set up, and you're able to hook into it and run all your programs through that and not on your Windows machine. So you don't have to do this weird SSH thing where you need to go into a different Linux environment, or again, you don't have to deal with Windows C++ compiling. So let's go through some basics of C++. So we need to ask ourselves first, how does a computer work? A computer, in programming at least, we have languages known as high-level and low-level. A high-level language is something that really resembles human language. In our case, English is what most programming languages resemble. And they allow us to write code that we humans can understand and we can share with other humans so that they can read our code and improve upon it. Low-level languages, however, is usually known as machine code. Typically, some languages, when you compile their code, we'll get into compilers in a second, when you compile their code, they make binary files. And these, or you might know them as executables. These executables are able to be read by a machine, such as your computer or a microcontroller. They're able to take these, read the binaries, the ones and zeros, and it knows what to do exactly by interpreting that, whereas it cannot understand exactly what we're trying to say when we say I handed a C++ file. It doesn't know how to read it. So, because we can't really write machine code, it would be either too painful, and I think it's impossible to manually write machine code or binary for a computer to read. So we use a thing called a compiler. Compilers take our language, our C++ in this case. It will take that high-level language and turn it into machine code. The job of the compiler is to make sure your syntax is correct and that you're doing everything correctly so that you're not misusing data types, you're not, including libraries that don't exist. Well, we'll get into this a little bit later when we make our Hello World program. Don't let the errors in the compiler discourage you. I know in C++ you're going to see some pretty weird and long compiler errors, but we don't need to worry about them just yet. Typically, you have to scroll to the very tippy top, and the very first line of the error will generally tell you what the issue is. A lot of the stuff that is spewed out in your console, we'll show it here, it's generally just cascading errors. It falls down through this rabbit hole. So, with all of this out of the way, this very quick run through, let's make our very first Hello World program. And I'm going to type this up really quickly. Let's see. Let me get my editor out. We will have, we will have to include our IO stream. We will have to include our namespace, our using standard namespace. We will then have to create our main function. That's the first function, and we'll describe functions later. Just know that the main function is always needed. It will be the first thing called when you run your program. It is how every program in C++ starts. Now, let's output Hello World to the console. What we're saying here with cout is we're saying output this string of letters, a string of characters, to our console in this case, or the buffer. Well, I won't get too into that. I fully can't explain it correctly. And then we'll say endl. So endl here is we're going to put a new line. It's like when you hit the enter key, it puts it on a new line for you. So now we're going to return 0. What return 0 means is that when the program finishes running, it's going to send this number 0 up to the computer saying, we have successfully ran your program. And 0 is usually what indicates to all computers that it was successful. Error codes generally use 1 or a different number that you might understand. You might have a custom error code that you want. So, now that we've written our wonderful Hello World program, let's compile it. We're going to use what's called G++. I hope I showed you a few minutes ago how to install that when we set up our WSL Linux environment. We are going to say G++, and I've named the file hello.cpp. So I'm going to put hello.cpp and hit enter. If you run a command called ls, we are going to see that it outputs this file information in our folder. What is this saying? It says we have a.out program. This is the default program or executable file name. To run it in WSL, we just do ./a.out. And if we run it, we get Hello World. Oh my god. If we want to, we can name our executable. So if I say G++ hello.cpp space -o, not the number, the letter, -o, and let's call it Hello World. Make sure not to name this the same thing as your file, because if you do, it's going to replace your code and then you're going to lose all your code with the executable. So now if I ls again, we can see now that I have a wonderful hello world executable. And if I run that again, ./hello world, we can see that it outputs the same exact thing. It's just a different executable name. I think it's easier if I compile most of these to a single letter like B, because I can do ./B and hit enter really quickly. It doesn't matter what you name it. I've never had a use case for naming it anything meaningful, but I haven't worked in a company that cares about naming your software programs executables. For today, I think this is all I'm going to try to cover. I know I've only intended to do 10 minutes, so I think this is about 10 minutes long. Next, I'm going to try to cover things like declaring and initializing variables. We're going to do types. We're going to learn const. And we might learn a few logical operators like and, or, and we might do greater than, less than. So thank you for listening. I'll see you in the next video.